Okay, my next example says 4 divided by x is less than x. 4 divided by x is less than x. So, same technique. If we move x to the left, we have 4 divided by x minus x over 1. I want to change it to a fraction, just like I've done on all examples. Again, our least common denominator is found by multiplying x times 1, which is x. So x goes into x 1 time. 1 times 4 is 4. 1 goes into x. X times x is x squared, and I write minus sign. And again, I ask that you refer to earlier examples. If I went through this a little bit too fast about how x goes into x 1 time and 1 goes into x time, there's an earlier example that we talked about and we discussed it in detail. This is actually less than 0. So now we see again now that there's actually one factoring technique that is left in this problem. This is a difference of 2 squares. This is a difference of 2 squares. And we factored one like this earlier. A difference of 2 squares tells us that this is going to be 2 minus x and 2 plus x all over x is less than 0. So the algebra is now over. Now only thing that we have to do is we have to actually take all of our factors, which in this case is actually 3, 2 minus x, 2 plus x, and x. We have to set all 3 of these equal to 0 to find our test points. Okay? So if we take 2 minus x, set it equal to 0, take 2 plus x, set it equal to 0, and take x, set it equal to 0, this one is already solved. So we know here clearly that 0 is a test point. Subtract 2 from both sides. This tells me that negative x is equal to negative 2. Divide both sides by negative 1 and x is equal to 2. This says if I subtract 2 from both sides, now x is equal to negative 2. So my 3 test points here will be 2, negative 2, and 0. Okay. So let me erase. I need to erase so I can get more space here to actually put my test points here. Negative 2, 0, and 2. Dotted line. So you should be getting very, very familiar with how to do these. So I put all 3 factors here. 2 minus x, 2 plus x, and x. A point to the left of negative 2, negative 5. 2, let's write this one out. 2 minus a negative 5. 2 minus a negative 5. This will actually be a negative times a negative is a positive, so 2 plus 5 is a positive answer. 2 plus a negative 5. 2 plus a negative 5, a positive times a negative is a negative. 2 minus 5 is a negative answer. We're trying negative 5, so when I substitute it in for x, it's still negative. A point between negative 2 and 0, like negative 1, 2 minus a negative 1, again will be 2 plus 1, which is a positive answer. 2 plus a negative 1 would actually be 2 minus 1, which is positive. And then since we're trying negative 1 here, x is negative 1, so it's negative. If I try to point to the in between 0 and 2, like 1, 2 minus 1 is positive. 2 plus 1 is positive. And since we're trying a positive 1, when we substitute it in for x, it's positive. To the right of 2, like 5, 2 minus 5 is negative. 2 plus 5 is positive. And 5 is a positive number. So we need only to investigate, when we get ready to consider, we only need to investigate the amount of negative signs that we have. Okay? And just to go ahead and do justice to explaining here, if we take these two and multiply, a positive times a negative is a negative. We then take that negative and divide it by another negative, that gives me a positive. So you only need to consider the amount of negative signs that you have. An even amount of negative signs will produce a positive, and an odd amount of negative signs will produce a negative, positive, and negative. Okay? And so since our problem asked for those solutions that will make us have negative solutions, we only want to consider the intervals between -2 and 0, and then 2 to infinity. We don't have to consider the test points this time because it only asks for those solutions that are strictly less than 0. So if I put these three numbers on the number line, -2, 0, and 2, all three will have open circles, and I illustrate this by shading in the middle and shading everything to the right of 2.